Hello everyone, welcome back to our channel Learn Tech with Kiran. In previous video, we explored the basic of finite state machine and how they help us in recognizing pattern within the input code. Whenever we design a finite automata, whether it is DFA or NFA, we need a clear structure way to show how the machine moves between states when it reads input. That's exactly what a transition table and transition diagram do. That's why we covered this topic in today's video. So let's move forward with transition diagram and table. First, we have to know about why it is needed for your TOC syllabus or for understand the further concept of your theory of computation. So let's start with why we need it. Imagine you are designing a digital circuit or a compiler or a text parser. Just knowing the state isn't enough. You need a clear way to describe what happens when a specific input is given or which state the machine will move to. This is where your transition table and transition diagram help. To understand transition diagram, move forward with your next topic, transition diagram and its notation. Transition diagram is nothing but a graphical version of your transition table. Each state is shown as a node and transition are arrows labeled with input symbol. In this input label, you can see your transition from Q1 state to Q2 state happen with a input symbol A. Your transition diagram helps us to visualize how the automata moves from one state to another. This is especially useful when we are trying to explain, debug or trace the working of NFA or DFA. Following some of notation used in transition diagram. Let's move forward with one by one. State. What is state? State is nothing but any specific configuration or condition of the system and it is represented by circle. Here state Q1 we shown in diagram. Move forward with initial state. The starting point of the any system operation indicated by an arrow pointing to the state without a source. You can see here no any other source is mentioned over here. Next, final state or accepting state. It indicates successful completion or a desired outcome. These states are represented by double circle as mentioned in your diagram. Next one is transition. Transition represented by directed arrow or edges connecting the different state. The arrow indicates the direction of movement between state. In this diagram, you can see from state Q1 to Q2, the transition is mentioned. Each transition arrow is labeled with the input symbol that cause the system to move from one state to another where your input label is in role. In this example, you can see from Q1 state to Q2 state transition is happened with input label A. Similarly, multiple inputs are there. If multiple input symbol cause the same transition, they are listed separated by commas on the same arrow. In this diagram, you can see from Q1 state to Q2 state transition is happened with multiple input label, that is A and B. We can use this notation in our example. Let's move forward with transition table. Transition table, it's nothing but your rule book, or it maps out how each state respond to the input. In your transition table, rows mentioned or rows denoted for current state and column usually describe your input symbol. This diagram is showing a transition diagram. For this transition diagram, there is a transition table, looks like this. You can see in rows there is your current state or states are mentioned, and in column there is input symbol which is A and B. As you can see in diagram, Q0, Q1 and Q2 are state which is mentioned in your row, and input symbol A and B mentioned in your column. Our transition table used to define state transition precisely, and it is also useful while we implementing the code. It will help us, or it is easier for implementing an code. In DFA, this table is precise and unique. Each input has exactly one transition from a state. And in NFA, the same input might lead to multiple possible next state. As we move forward with playlist, we will check on DFA and NFA problem, where you can see how DFA contain precise and unique states as well as input, and your NFA contain multiple possible next state. As we can see the transition table and transition diagram in this video, there is one question raised in your mind. Why are these representation important? Because they help us to understand the behavior of automata, whether it is DFA or NFA, step by step. They are essential for constructing and analyzing automata, especially when solving the problems in compiler, lexical analyzer and pattern recognition. They form the base for converting NFA to DFA and for minimizing DFA. Let's move forward with example where you can see how transition table and transition diagram can be useful. One quick example: design a deterministic finite automata that accept all string over the alphabet such that the string contains at least one occurrence of A, the string contains at least one occurrence of B, and the string end with B. This is DFA designed for above problem statement. As we move forward with DFA and NFA problem, you can see how DFA transition diagram will design. So this is the language for which this DFA diagram, DFA transition diagram will design. If you precisely see your language and your DFA diagram, the language will accept by this DFA. In next DFA video, we will see how precisely this DFA diagram or transition diagram will design. Now we can see how this transition table will design from this transition diagram. So there is Q0 state. From Q0 with transition input label A, we go to the Q1. So look in this table, Q0 with input label A, your state reached to Q1 state. With input symbol B, Q0 state reached to the Q0 state itself. For Q1 state, there is input symbol A. With input symbol A goes to the Q1 state itself, and with B transition input symbol, your Q2 state transition move to the Q2 state. For Q2 state, with input symbol A, your transition move to the Q1 state, and from Q2 state with transition input symbol B, your transition move to the Q2 state itself. This is the way to design your transition table from your transition diagram, or your transition diagram draw from your given input language. So transition diagram help us to visualize how automata moves from one state to another state or between state, while transition table give us a structured way to represent those moves. Together, they make designing, debugging and understanding DFA and NFA much easier. That's it for today. In the next video, we will continue exploring more important topics from theory of computation. Don't forget to like, share and subscribe to support the channel and stay updated. Thanks for watching. See you in the next one.